Assalamualaikum and hello everyone. My name is Hamzah Razik Khan bin Azam Khan, and today I would like to present my final year project 2, which title is Prediction of Brain Stroke Occurrence Using Supervised Machine Learning. And my supervisor is Dr. Izan Izzati binti Kamsani. So for today's agenda, we will discuss 6 chapters, which is Chapter 1, Introduction, Chapter 2, Literature Review, Chapter 3, Research Methodology, Chapter 4, Experiment, and Chapter 5, Research Result, and Chapter 6, the Conclusion. So Chapter 1, the Introduction. Stroke is a serious medical condition identified by an abrupt interruption of blood flow to the brain. Risk factors for stroke include high blood pressure, diabetes, and smoking. Due to their reliance on static risk factors and limited predictive abilities, traditional methods of predicting stroke may not be as effective today because they frequently ignore dynamic factors and individual variation in disease progression and response to treatment. So, machine learning has demonstrated the potential for identifying unknown threats, such as brain stroke. This research project focuses on using supervised machine learning methods to improve stroke prediction precision and efficiency. The chosen method is support vector machine (SVM). It is because it is a very popular machine learning method. So the research background: stroke can be fatal or cause significant disability, and they are the leading cause of long-term disability worldwide. Symptoms of a stroke can include numbness or weakness in the face, arm, or leg, especially on one side of the body that occurs suddenly. Early recognition and treatment of stroke are critical for improving patient outcomes. This model that predicts the occurrence of brain stroke will hopefully tackle this with accurate precision. In the research statement, brain stroke is a significant public health challenge with 15 million cases worldwide annually, leading to death and disability. Early detection and treatment are crucial for improving patient outcomes. So in machine learning algorithms such as supervised learning hold promise in healthcare applications, including predicting medical conditions. Supervised learning model learn from label trained data to make accurate prediction or classification on new or future data. Developing a predictive model for brain stroke using supervised machine learning could be a promising solution. By training the model on a dataset of risk factors and using it to predict stroke likelihood, which can improve stroke prevention, early intervention, patient outcomes, and reduce healthcare costs. So the research aim and goal is to create a predictive model for brain stroke by comparing the performance from previous studies using supervised machine learning, namely support vector machine, using brain stroke dataset, and choosing the best method with high performance for brain stroke prediction research. And the goal is to develop a more efficient and accurate method of predicting stroke risk, which could allow for earlier intervention and potentially reduce the burden of stroke on individuals, families, and healthcare system. So the question for this research consists of 3. The first is how does supervised machine learning algorithm can be evaluated and used for predicting brain stroke. The second question is how to develop a predictive model like support vector machine. And the third question is how to evaluate the performance measurement using support vector machine. So we have our objective, which are to understand how supervised machine learning algorithm to be evaluated and used for predicting brain stroke. Second is to develop a support vector machine predictive model to testing on brain stroke dataset. And the third objective is to evaluate the performance measurement using support vector machine in predicting brain stroke occurrence. The scope for this research is by using a dataset from Kaggle to evaluate machine learning prediction, to analyze and compare the result obtained from the research, and to determine the best learning prediction method for this project. So we move on to Chapter 2, which is the literature review. So what is brain stroke? Brain stroke, also known as cerebrovascular accident, is a medical condition that occurs when the blood supply to a portion of the brain is cut off or reduced. So about the machine learning, there are three concepts of machine learning, which is supervised, unsupervised, and reinforced learning. Supervised learning algorithm is used to predict the occurrence of brain stroke. The example for supervised machine learning is random forest, naive Bayes, SGBoost, support vector machine. All can be used to predict or used to develop a prediction model. So in the end, we use SVM to predict the brain stroke occurrence. The next chapter is chapter 3, the research methodology. So in this research, there are 3 phases throughout the study, which the first is to create the literature review and to determine the problem. So the second phase is a well-formed stroke data set is provided for the experiment during the data gathering and data processing. After that, the development of the SB model will be constructed. The third and the last phase is testing and evaluation for the effectiveness of the classification method used in the study is evaluated and compared with the performance of other methods. So on the right, we can see the figure for the research framework. So we start and we go to the phase 1, which is the research review and prior studies, which consists of literature review and problem determination. In the second phase, we design, develop, and implementation by data gathering and pre-processing and the development of SVM model. And the third phase is for testing and evaluation. We use performance measurement to evaluate and to determine the score from the SVM model. And after that, we document and report and the end. So in the performance measurement, the accuracy, F1 score, precision, and recall of the performance measurement for stroke prediction are used in the study. Other than that, conversion matrix will be used to accurately measure the performance of the machine learning models, particularly the SVM model. There are 4 types of measurement, which is the accuracy, precision, recall, and F1 score. Next, we talk about the synthetic minority oversampling technique, SMOTE. It is used to address class imbalance in dataset, which is common in stroke prediction. Balances the dataset by increasing minority class instances. It helps improve predictive performance for minority class and is crucial for accurate stroke prediction model, which often have fewer stroke event compared to non-stroke event. So we have our dataset, which is selected from Kaggle. The predict stroke likelihood based on parameters like gender, age, diseases, and smoking status. It consists of only one file, which have 5,110 rows and 12 columns or features. Then we move on to chapter 4, which is the core element of the research, the experiment. So in the proposed model, the dataset for the study was first obtained from the Kaggle repository and was assigned as patient stroke dataset. The raw dataset will be handled in terms of determining whether any values are missing and normalizing the data to ensure that it produces the desired analysis process result. Before moving on to the development phase, a feature selection approach has been performed and put into practice. As we all know, feature selection will be one of the most crucial components in the development of machine learning, whereas a number of characteristics in the dataset will need to be filtered and the best feature will be chosen for the model. Both classifier, which is SVM, get the appropriate attributes as inputs during the classification phase. So in our data introduction, you can see that only 5% of patients have stroke, and the other 95% are healthy, which have no stroke, which can cause the data imbalance. So we need to do our data preprocessing. It refers to the steps and techniques involved in preparing raw data for analysis or machine learning tasks. It seeks to transform the data into a suitable format that algorithms and models may use efficiently and accurately. Data inconsistencies, missing values, outliers, and other issues with data quality can negatively impact the performance for analytical and predictive models. So there are categorical and numerical data. The data set include a mix of categorical and numerical features with data missing from the BMI feature. The categorical features present are gender, alphanumeric, work type, resident type, and smoking status. The binary numerical features include hypertension, heart disease, and stroke. So the continuous numerical features consist only 3, which is age, average glucose level, and the BMI. So in the continuous numerical data in the search, the continuous features present a different set of challenges and opportunities for analysis. Given that BMI data is missing, it may be necessary to employ imputation techniques to fill in the gaps, ensuring the completeness and reliability of any subsequent analysis. So first we need to handle the missing values. Missing value can affect model accuracy. Data validation is crucial to address this. The dataset used in the study contains missing values, notably in BMI data. Mean value replacement can fill this gap, ensuring completeness and reliability for analysis. You can see from the left, only BMI column has missing values, so we replace the missing value with mean values, and the result is the missing values have been handled and there is no missing value in the dataset anymore. Next, we handle data outliers. Outliers significantly different data points can skew analysis and machine learning result. Examine average glucose level and BMI columns for outliers. Use interquartile range IQR for detection. There have been 627 detected outliers for average glucose level and 126 for BMI. So we need to eliminate the outliers to ensure data integrity. No outliers remain out after adjustment. So in the left we can see that data outliers is present. After we handle data outliers, we have a better result and better data integrity. Next, we use one-hot encoding function to transform categorical data into binary format for machine learning. Dataset, which include 5,110 entries or rows, separate into 16 columns representing health and demographics. After encoding, categorical variable become Boolean column. For example, gender into gender male and gender female. The get dummies from pandas library function will be used for the encoding to ensure no multicollinearity among columns post encoding. So the figure illustrates correlation matrix scores after encoding, which in the highest point is the stroke, which the most correlated, and the second is the age, which is 0.25. So the below 0, which is smoking status, never smoke, work type never work, and work type children are all don't correlate with the encoding. Next, we handle our data imbalance, which is data balancing. It is crucial for unbiased model performance. SMOT, or synthetic minority oversampling technique, was employed in this study to address data imbalance. Before SMOT, the dataset had 5,109 samples with a significant positive class imbalance. After we used SMOT, the dataset was balanced with 9,720 samples, evenly split between positive and negative samples. SMOT generates synthetic minority class examples, ensuring balance without duplicating existing instances. Next, we normalize the data. Data normalization ensures consistent feature scales across dataset. It is crucial for fair evaluation in machine learning algorithm, and it prevents larger features from overshadowing smaller ones. We use min-max scaling, which is common technique for normalization. So the rescale features to a specified range is typically 0 to 1. So we preserve relative relationships between the data points. On the left, we can see before using min-max scaling, the age, average school cost level, and BMI is not normal. So after we use the min-max scaling, we have better result with after using data normalization. The next step is to select the features by using the select k-best and chi-square. Select k-best efficiently identifies top features using statistical tests like chi-square, reducing dimensionality and enhancing model performance. In the chi-square test, it evaluates categorical data association using X by the power of 2 statistic. High values indicate strong association, aiding effective feature selection for machine learning. So after we do the chi-square test, you can see that age, average glucose level, and age and average glucose level is the highest for all the features, which is 3,144 and 1,775 respectively. Next, we select the top best features. After we do the chi-square test. Feature selection crucial in machine learning pipeline to improve model performance. Enhance accuracy, reduce overfitting, decrease complexity. We use select k-best with chi-square test to rank features based on significance. So we compare the top 9, top 6, and top 3 features set to balance accuracy and complexity. In the end, the top 9 features yielded highest accuracy, indicating feature selection importance. So we select more features that can enhance model performance and accuracy. This can enable capturing complex relationship and patterns in data. It provides more information for better discrimination between categories. Prevents fitting by learning from richer data representation. Prioritize informative features, improving model focus and accuracy, which results in better performance by capturing richer data distribution and representation. So we can see from the table that the top features, the top 9 has the highest accuracy, so we choose top 9. So the table below it is before we do the feature selection and after feature selection. So next is data splitting. It is crucial for model robustness and generalization. By training, the training set defines model parameters, discover patterns. Test set assesses model performance on new data. So we implement and utilize the train test split function from scikit-learn, splits data set into training and testing subset. Then train the set teaches model pattern and relationship, and we test the set to evaluate the model's prediction accuracy on new data. So the variable assignment, we use output assign to xtrain, xtest, ytrain, and ytest. Represent input features and corresponding target labels. So we specify the proportion for testing, that is 20% testing data and 80% train data. Next, we build the support vector machine model. So we construct post data processing and feature selection. The loop is to build models, assess prediction task time. The conclusion matrix evaluates model accuracy, and the support vector classification is utilized after hypermap parameter tuning. So in the model training evaluation, SBN instantiated with specified parameters. So we train on the training data, and the predictions made on test. Predictions are made on test set. So we can get the accuracy computed using accuracy score function. In the end, we get the test accuracy, which is 89.76%, which indicate percentage of correctly classified sample. In the classification report computes precision, recall, F1 score, and support for each class, providing insight into model performance in chapter 5. So we can see that In this research we get the accuracy score of 0.89. To compare from previous study, which is 0.79, which in this research is better result. So in chapter 5, which is the research result, in the confusion matrix, it provides detailed analysis of SVM model's performance. It compares actual stroke classification with model prediction and classifies prediction into true positive, true negative, false positive, and false negative. In the end, we get the evaluation matrix, which is the accuracy, precision, recall, and F1 score. Accuracy is for the overall effectiveness percentage, and the precision is to reduce false positive. Recall is to identify actual stroke cases, and F1 score to balance assessment of precision and recall. So ultimately, we get our score compared to the previous study. So in conclusion, the research aimed to use supervised machine learning to predict the occurrence of brain stroke. The methodology involves data pre-processing, feature selection, and model development. The results show that the model is effective in predicting brain stroke. So throughout the research, we achieve by applying data pre-processing and feature selection, we achieve an accuracy that outperforms previous model. We achieve better recall, precision, and F1 score. And we develop and train a SVM model using for stroke prediction, incorporating data cleaning, chi-square, feature selection, and hyperparameter tuning. So in the future works, we can improve the research by using data expansion. It incorporate diverse data set from various geographic location and real-time patient information to improve model resilience and address demographic difference in stroke risk factors. We can also use different algorithms such as neural network or deep learning, random forest, and SIBUS, and so on to identify the best performing stroke prediction technique. And then we can use feature engineering, which is used to feature extraction and transformation and to discover additional stroke predictors and enhance model accuracy. Okay, that's all for me. Thank you for watching this presentation. Thank you. Assalamualaikum.